Hi gang, Stat1800. In this video, I will work, I guess this is the final video of lesson number 2, which is demo number 3, lesson number 2, where we transition into continuous distributions and normal distributions. So let's see what happens. Again, just to speed things up, I've already entered the answer, so I'm going to show you how to work the problems. So, all right, so we have a standard normal distribution, which means we have a mean of 0, standard deviation of 1, and we need to calculate some probabilities. So the very first thing I need to do is I need to bring up StatCrunch and have this available. All right, well, it looks like I already had it available, so I just wasted your time. Now, first of all, I want you to completely get out of your mind using these stupid cumulative standardized normal distributions. They're antiquated, they're dumb. They're just not the right way to do these problems, in my opinion. We have technology, right? Let's use it because it's much easier. So we're looking at a normal distribution probability. So I'm just going to go to stat to my calculator and obvious choice, normal distribution. Now I can set my mean in 0, my standard deviation of 1. I need a probability that z is less than 1.04. And I get it. If I did that using the table, I will guarantee you that you couldn't have done it that quickly. What's the probability that z is greater than negative 0.27? Well, 0.6064. What is the probability that z is less than negative 0.27 and greater than the mean? Now, this gets into something we studied earlier, the probability of this or that, and we have to subtract out the probability of and happening, right? But you can't be higher than the mean and less than 0.27, so that probability is 0. So all we have to do is just add the probabilities. So I know that less than 0.27 has a probability, I'm sorry, this is greater, so I need to not get sloppy here. So less than negative 0.27 is 0.3935, greater than the mean. The mean is 0. It's just 0.5. So I just add 0.5 plus the answer I just got to get 0.8963. Same thing, less than negative 0.27. So I need to take 0.394 and add that to the probability of greater than 1.04. Which is 0.149. And you'll see I get well, probably help if you could see this. You get 0.543. A lot going on here. All right, let's go into question 2. Question 2 deals with the normal distribution that doesn't have mean 0 or standard deviation 1. So it deals with pertains to a standard normal distribution that is not the standard normal distribution. But the beauty of it, all this stuff works the same. So we have a mean of 47, standard deviation of 4, What's the probability that x is greater than 40? You can see it's 0.9599. What's the probability that x is less than 39? Now, one thing, less than, or equal to, and normal distributions, they're the same thing, so we don't have to worry about that. So 0.0228. For this distribution, 5% of the values are less than what x? Well, this is asking us to find this value, where the 39 is, by putting in a value for the percentage. So what I need is 5% less, so I need to put a 0.05 here, and work backwards to calculate the value. So if I round to the nearest integer, you can see the 40.42 is just rounded to 40. So anyway, I put the answer, so to speak, the area, and again, I want 5% less than or equal to, and I need 5% less, so that's the reason I entered those. Between what two x values symmetrically around the mean are the 70% of the values? Well, I don't think I've shown this yet, but I have a between option. So I need the between to be 70%. I can compute the two values. So the left would be 43, rounded to the nearest integer. The right would be 51, rounded to the nearest integer. All right, trucks. Looks like a truck has a mean of 50,000. Looks like it has a standard deviation of 10,000. So what proportion of trucks can be expected to travel between 38 and 50? So I need the between for this one. So 0.3849, or rounded correctly, 0.3850. What percentage of trucks can be expected to travel less than 40 or more than 70? I need to go back to the standard and calculate less than 40. So I'm going to take 0.1587 and add it to the population of greater than 50. So I add those two answers together. I get, wait a minute, my bad. Got in another problem. B says 70. So I take the less than 40 and add the answer to greater than 70. And I enter this as a percentage. I tell you what, I don't want to get sloppy on this. Let me show you. So the answer to this is 0.02275. And the less than 40 is 0.15866. Let me move everything out of the way to where you can actually see what I'm doing. So you can see I added those, and if I multiply by 100 to convert it to a percentage, you see I get 18.1%, 15%. How many miles will be traveled by the least 60% of the trucks? Well, what I need here is I need less than or equal to, I need 0.60 here. I got sloppy when I entered the answer in. Wait a minute, the number will be traveled by at least. So that's actually, at least is greater than. So I can see what I entered was 47.5, so I got sloppy, and it counted off. So I didn't feel like redoing all the complete assignments, so I just left it. So just make sure you put this in thousands. So it's, come over to here, it's 47,467. How would your answers change? Uh, all you got to do there is just come in and change the standard deviation to 7 and work all the problems again. I'm not going to do that because there's nothing different than what we did previously. All you have to do is just change the standard deviation to 7 and go for it. All right, final question. We have a set of exam grades, mean of 77. So let's get that with a standard deviation of 7. First question is the probability we'll score below an 89. 0.9568. What is the probability this student will score between 70 and 95? I'm going to go up and grab the between function and put 70 and 95. So I get 0.8363. The probability is 25% that a student taking a test scores higher than what grade. So I need to go back to standard. I need this to be greater than 0.25. So the score is 82 because it wants us to round to the nearest integer. Now, the next question gets into z-scores. And z-scores, have been taught in a previous video. So the way we calculate a z-score is to take the score minus the mean and divide it by the standard deviation, which absolutely does no good to you because you can't see what I'm writing. So what I need to do with the first one, it says if a professor grades on a curve, is a student better off with a grade of 91 on the exam with a mean of 77, standard deviation of 7? So I can calculate the z-score for this person. And you can see I get the z-score of 2. And the other score scenario is they scored a 63. No, they didn't either. They scored a 67 with a mean of 63 and a standard deviation of 4. Well, you can do that one in your head probably. At least I can. So you see a standard deviation of 1. So since this z-score is higher, I said a student is better off for the grade of 91 on this score because the z-value is 2 and the z-value for the other score is equal to 1. All right, gang, that's all I got. Take care.